Good morning, class. Just wanted to go ahead and go through the atomic theory. And this is not hard. In fact, we've already talked about this a little bit on page 629, lesson 6. Okay. And this is a building in Brussels, Belgium. Isn't that cool? They have windows here. And it's called the Atomium. Atomium. Okay, and it's shaped like an atom, so that's why it looks like that. So we're going to go through this a little bit, and I'm trying something new. I've got it kind of rigged here at my house, so we'll see if it goes okay. So I'll be using the camera to zoom in and out, so hopefully this will work for you. Okay, all right, on page 630. Okay, a teeny tiny theory, okay, that we're going to be looking at. Okay, so then more than 2,000 years ago, I stated that all matter is made of tiny solid balls called atoms. The word atom means indivisible, meaning it can't divide it. You can't divide it. So this scientist is called Democritus, and he's credited with the naming or calling them atoms. So we're going to be talking about atoms. Here on the purple you can see Democritus. It says, suppose you could break a silver chain into smaller and smaller pieces. The pieces would become so small that you couldn't see them without a microscope. How small could the pieces get before they were no longer silver? The answer is one silver atom. An atom is the smallest unit of an element that maintains that properties of that element. Okay, and we've discussed atoms. We talk about matter. We've been talking about matter and the different states of matter and their properties. And we talk about particles or atoms in solids, like even in your desk or your chair. They're still vibrating even though it's a solid. And because all matter or all the atoms still move. We just cannot see it with our naked eye because it's so small. And we've already discussed all this, so this shouldn't be anything brand new. And I am so sorry I'm reading this to you, but I like to go through that. You know, we usually have discussion and you guys ask questions, and we talk about things that you guys bring up. So I am so sorry that we're not doing that right now. The atomic theory is a scientific explanation of the structure of atoms and how they interact with other atoms. So remember the atomic theory, it's a theory. So theories from the scientific method that you learned have evidence towards it, that support it, and evidence against it. Democritus first suggested that the smallest part of matter is an atom. Over the years, theories that scientists made about atoms have changed as scientists learn more about atoms. And here's gold, okay, and it's an element. Now this is a gold brick, so it's one type of matter, flakes of gold, okay. And then here, they even magnify it greater. So this is a gold brick, and then you have flakes of gold, and then they magnify it even more, and then they have these itty bitty gold atoms. And so one of these itty bitty little round things is an atom. So obviously we can't see these round things here in the gold bricks. Okay, so that's pointing to a single gold atom. Okay, so atoms are the building blocks of all matter that we've been talking about. Current atomic theory states that an atom is mostly empty space. At its center, there's a small, dense core called the nucleus. The nucleus is surrounded by electrons. Okay, so when we talk about an atom, there's three particles that make up an atom. You have a proton, and I drew this with a positive sign, okay, and a proton, let me get this, there, okay, a proton is positively charged particle found in the nucleus of an atom. Then you have a neutron, and it is neutral, meaning it doesn't have a charge. So we show that by doing plus, slash, minus. Neutrons are also found in the nucleus, but a neutron has no charge. Then we have an electron, okay? These are negatively charged, and they speed through an area around the nucleus called the, guess what, electron cloud. And you guys, we did talk about this before with an atom. I know we did. We talked about the two parts of an atom. Okay. Oh, that might be helpful if you could see it, huh? Two parts of an atom. Not much different than class, is it? Okay, so we have our nucleus. Okay, and in there we have protons and neutrons. And protons, positively charged. You guys, easy way to remember this, P, starts with a P, positive. Neutrons, it's neutral. Those are easy to remember. Those are easy. So those are in your nucleus. So that's kind of in the center. Okay, and I'm going to do P for protons, N for neutrons. Okay, in that round circle. Then we have the electron cloud. And remember, we talked about this before. And the electron cloud, guess what? You guys were smart because you knew this before. Electron cloud contains electrons. And they are negative. They're negatively charged. So it's a cloud. So they're in constant motion, aren't they? So they're just boogieing around the nucleus. Okay. Now, easy, think about this. Electrons, this is where we get electricity. Because when we pass electricity through atoms, the atoms become excited and they start moving around, and that charge is passed. And it's the outermost of the cloud. Okay? Cinco's wanting Mom's attention. Just like he always does. Okay, if you can hear him in the background. So this is the electron cloud, which contains electrons. Okay? So we had talked about this before. It's been a while, but we have discussed this. So this is nothing new. It's something we had kind of talked about, so this should be kind of a review for you. Okay. So, let's go ahead and go to page 632. Okay. Now, we're moving on. Okay, we talked about atoms. So that should be a nice review. Then we have elements. Elements, this is the next one. And this is, our scientist is Mendeleev. And you can, it's hard to read his name, but it's right there under his picture. In the mid-1800s, I organized all known elements by their properties and increasing mass. Scientists still organize elements based on my work, and that's the periodic table of elements. And we had kind of looked at those before. You guys have asked me questions about that. And you guys know properties, just like we talked about properties of matter, like color and texture, and size and shape, the state of matter, solid, liquid, and gas. So we've all talked about those before. So those are all properties. Okay? So it's elementary. Copper, oxygen, mercury have all one thing in common. They are all elements. So exactly what is an element? Okay? There are many kinds of matter, which we've already talked about that. An element is the type of matter made of just one kind of atom. Okay? All atoms of an element have the same number of protons. Same number of protons. Okay? For example, boron, B-O-R-O-N, boron, is an element. Every atom of boron contains exactly 5 protons. No other element has atoms with exactly 5 protons. What's so special about protons? Electrons are far from the nucleus, right? So they are going around the nucleus in their electron cloud. Okay? They're in constant motion, like bees around a beehive. You can kind of think of it that way. Electrons are far from the nucleus, so they can be gained or lost. Also, different atoms of the same element can contain different numbers of neutrons. Protons always stay the same, always the same. Okay? So I know it might be a little bit confusing, but you have atoms. Okay? Atoms, they are all one kind of atom that make up an element. An element. Okay? And elements are naturally found in our Earth. There's 92 of them that are naturally found somewhere in our Earth. Okay? So that's what an element is. Okay, so here we have several elements. Neon. Okay, neon, you guys have heard and seen neon signs, right? Okay, and I'm still on page 632. Okay, so neon has 10 protons. We use them for neon signs, helium neon lasers, television tubes, and even in refrigerant that we use to cool down for our cooling of our refrigerators and in our air conditioners in our car, refrigerant. Okay, mercury. Okay, remember we've talked about mercury when I was a little kid. That's what we had, mercury thermometers. Okay, we had mercury thermometers. Now they use alcohol, different types of alcohols in them to make them safe because mercury is can be easily absorbed into your skin. Okay, so mercury, there are 80 protons in mercury. 80 protons in mercury. All right. They are used in laboratory instruments, thermostats, dental fillings, and in pesticides. Okay, mercury. So obviously, if it's not healthy for humans, pesticides meaning that's what they use to kill or to get rid of different types of insects, okay, or pests. So that's what they're used for, okay. So sometimes they talk about mercury poisoning in water and things, so that's why pesticides are regulated for things like on the farm and things, and I have to register if I use any, but I haven't been using them since I've been doing the no-till. We've talked about that, so I don't have to use pesticides anymore. Okay, so here's some other ones. Elements, okay. Elements are substances that can't be broken down or broken into simpler substance. So an element is an element, okay? So if I have pure gold, I'll just keep breaking it down to gold, gold, and gold, and gold, and gold atoms, just like that picture showed previously on the atoms, okay? Okay, and I'm over here on page 633. Chlorine has 17 protons. Because remember, protons are always the same. Protons are always the same. Okay? So chlorine, you guys are familiar with chlorine. We disinfect water, chlorine for your pools. Making paper, paints, plastics, and dyes. Okay, so that's what chlorine is used for. Silver. Okay, silver. just like our silverware, our spoons, our forks, our knives, our jewelry, okay? And then remember, we talked about alloys the other day, okay? Those of you that weren't called out for your Chromebook, I apologize for that. But hopefully, remember, alloys are mixtures of metals. So alloys are mixtures of all these different elements. So silver, there's 47 protons, and you do not have to memorize these numbers of protons for each. They're just explaining it to you. But jewelry, silverware, photography, welding solder, and mirrors. Okay, so there's different types of welding solder. It depends on what kind of metals you are welding according to different solder that you talked about. Okay, and then you have copper. Okay, so copper has 29 protons. 29 protons, and the uses are for plumbing, coins, electrical wires, and then guess what, guys? Making brass and bronze. And aren't these alloys? Remember, brass and bronze are alloys. Okay? So they have other metals in them as well. Other metals / elements. Okay? All right. So they're saying draw and label a carbon atom. And you're going, oh goodness, I don't know how to draw that. Okay. So it's just like everything else. You guys can draw out plans of plays for football or basketball, or draw out plans of how to build something, or your model airplanes, or whatever you're working on. Okay, so a carbon atom. So what we're going to look at, okay, is down here. They're giving us 6 protons, 6 neutrons, and 6 electrons. Okay, so that's carbon. Okay, so we have a carbon atom. Oop, might help if Miss Gosen spells right. Carbon atom, and we're just drawing it out to show the different particles, which are the protons, neutrons, and electrons. Now remember, which one always stays the same? It's your protons, always the same. Okay, electrons they're on the outside, so they can be gained or lost, and we're going to talk about that here in just a minute. But your carbon atom, okay, so let's just start with like we did here, right? Don't we have a nucleus in the very center? So guess what? I'm going to draw my circle, okay? And it says, and what do I find in the nucleus? Well, I find protons and I find neutrons, okay? So, and they gave us how many there are, 6 protons and 6 neutrons. And this is on page 633, okay, down at the bottom. So all I do is go 6 protons, P, 6P, and 6 neutrons, N. So 6 protons, 6 neutrons. And I have how many electrons? Well, it says I have 6 electrons. And those are found outside, aren't they? Okay. All right. So we have 6 electrons. So we'll have 6. And I'm going to do E, and this is how they signify it with a little hash mark. 6 electrons. Okay? Okay? All right. And that's in my electron cloud. Okay? Okay. Okay, page 634. 634. 634. Okay, now we're moving on to compounds. compounds. So we talked about atoms. They are the smallest particle of matter. Then all of my atoms are my elements. There's 92 naturally found elements in the earth somewhere. Okay? And then we have compounds. So, what do we think? Atoms make up elements. Elements make up compounds. We can make that assumption maybe, can't we? So let's read on and find out. Okay? So here is Mr. Dalton, D-A-L-T-O-N, Dalton. And he's another scientist that came up with, guess what? The atomic theory. It stated that different types of atoms combine to form, guess what? Chemical compounds. Okay? Chemical compounds. Okay. Now, it says putting it all together. There are more than 100 elements. Now, and you said, but Miss Gosen, you just said there's only 92. And I said, yes, naturally found elements somewhere in the earth. On the periodic table, there are more than 100, but those are man-made, above 92. So those are man-made. So that's what I was referring to. So there's 92 natural elements. Okay? But you can see there are many more types of matter than that. What are these other types? Okay? Many atoms go through chemical change with a different type of atom and form molecules. Molecules. Okay? So a molecule is made up of two or more atoms joined together chemically. Okay, and we've been talking about chemical and physical changes. So, a molecule is made up of two or more atoms. A compound, okay, and this is a little bit different, a little bit difficult, because there's not much difference between them here. A compound is a substance formed by atoms from two or more elements. Okay? Now, we're not getting into too much chemistry here. There is a difference that you'll learn in more detail later on. But now, this is more I want for you to be introduced to this terminology of a molecule and a compound. Okay? So, that's what those are, a molecule and a compound. Okay. The properties of a compound are often different from the properties of the elements that form it. Well, yeah, because guess what, guys? Remember, we've talked about this. If they're joined chemically, then there's a new substance and they're changed, right? We've been talking about that for quite a while. Okay? So, example, atoms of carbon and oxygen will react, forming the compound carbon dioxide. Carbon dioxide. This compound has its own properties that are different than those of carbon, individual carbon, and individual oxygen. Okay? Now, I wrote this here for you. Okay? So let's just talk about that. And we've kind of looked at this before. This too is not brand new to you, right? Okay, we've talked about carbon dioxide because we've talked about the carbon-oxygen cycle, right? We give off carbon dioxide, and my plants, what? They need carbon dioxide. Remember, that's why I always talk to my plants, remember? So I give them a little bit of a carbon dioxide boost, and then they give me oxygen in my house and in my room. Just like the plant there in my classroom. Okay, so carbon dioxide. So I have what? One atom of carbon, correct? And I have what? Two atoms of oxygen. Okay? All right. So, now let's talk about the difference. So that is a molecule, isn't it? Okay? Or a compound. Okay? Now let's look at this one. CO. Okay? C, I have one carbon, or one atom, carbon. Okay? One atom of oxygen. Okay, now obviously we can't see these because they're both gases, correct? Their state is they are in a gas state. That's how they are. Both of them are. Okay, but carbon monoxide, that is carbon monoxide. Okay, and we've talked about that also. Mono means one. This one is carbon dioxide. Okay, and we've looked at that before as well. Di means two. Okay, so we give off carbon dioxide, right? And in our lungs exchange oxygen for carbon dioxide. Okay, carbon monoxide, remember, that's poisonous to us. That can actually kill us if we have too much, and we've talked about that. Because what that does is that binds to the hemoglobin, which is a protein in our blood, and doesn't allow oxygen to bind. So we can't carry our oxygen, and so that's why you start feeling tired, and you can't walk, and you're groggy, and you kind of get sick maybe. So, and that is what is produced from emissions from your certain heaters, okay, if you have certain types of heaters. And we've already talked about that, not having your generators inside your garage, right? You need to make sure they're outside. And don't run your car in your garage for long extended periods of time. So we talked about that as well. So this should be kind of a reminder, because I know you guys have asked questions over the year, and so this kind of brings up different things. So now we get to actually re-look at these again. Okay. Now, so let's go back to our book. That's kind of a review. Okay. So here on page 634, we have our hydrogen atoms. And how many do we have? Two little blue balls. Okay. And we have one oxygen atom. And you guys know this, right? As water. Kind of looks like a Mickey Mouse head, doesn't it? Okay, and that's actually kind of how they look. Okay, they look like little Mickey Mouse heads. So here's his ears and his little face. So H2O. And you guys know that because we've talked about water. Okay? All right. And another one, look at the difference of this. Okay, just like carbon and oxygen together. Okay? So you know water, right? We have two hydrogen atoms, one oxygen atom. Now, guess what? If we add H2O2, guess what? Chemically, so doesn't it totally change it? This is hydrogen peroxide. That's what your mom might put on some some boo-boos that you guys have, or cuts or wounds, and it bubbles up if you have anything, kind of bubbles up because it kills whatever's there. Okay, so we have two hydrogen atoms, the same as water, but guess what, guys? We have two oxygen atoms, and it totally changes it into a new chemical. Okay, do not drink this, okay, but we have to have water for living, right? All animals, plants, we do, okay, everybody has to have water to live, right? Isn't that amazing? So just one little extra atom totally changes it into something new. Okay, pretty cool, I think. Pretty cool stuff. Chemistry's fun. You'll love it when you get there one of these days. Okay, then we have sodium atoms, the little red ones, and we have chlorine atoms, okay? And they look a little bit bigger, don't they, in size? So sodium and chlorine makes, salt. Salt, like your table salt that you guys use, okay? And you're going, NaCl. Sodium, because sodium is Na. That's what it is, okay? Sodium, just like hydrogen is an H, oxygen is an O, and sodium, you're going, well, Miss Gosen, how come it's not SO? Well, sodium comes from the Greek word natrium, okay? Natrium. Okay, so before they started having a good classification system, that's where that word came from, is natrium. If I can do that. Natrium. Natrium. And that's kind of hard. I'm going in and out, zooming in on my camera, guys. It doesn't focus very well. I'm so sorry. This is just a little camera I had bought on my own, so if I couldn't get into town, then I'd have something here at home for this. So just be patient with me. I appreciate that. And yes, I'm on my stove because I have better lighting over here. I don't have good overhead lighting. So, and I can hang my camera. Okay, so that's natrium, Na. So that's where that came from, okay? And they do have a way of writing it. I don't know if you've noticed that, and you're going, well, capital N, little a, capital C, little L, okay? So there is, believe it or not, a rule of how they write this as well, okay? So just like this, carbon monoxide, if you'll notice, both of them are capitalized, correct? Okay, so, and you're going, well, but how do you know? Okay, CO, capital, capital, okay, and then look at this, okay, and you're going, whoa, is that a difference? Yes, this is the compound carbon monoxide, just like we said, right? Monoxide, 1 oxygen, okay? This is the element cobalt. And you're going, Miss Gosen, how am I supposed to know that? And you don't, but I just was wanting to show you why you're seeing it this way for sodium, Na, and then chlorine is Cl. Okay? So you have sodium and you have chlorine. Okay? And that came, like we said, natrium was the Greek name or word for sodium. Okay? So that's just some little bit of historical things that I think is very interesting, but also hopefully that will help you understand why things are the way they are. Okay? All right. So just to kind of let you know the difference on that. Okay? All right. Okay. All right. Sorry about that. That's my mom-in-law probably checking. Yeah. Oh, no, I'm fine. No, that's okay. Okay? Okay, I'll call you back in just a moment. Okay? Okay, sorry about that, guys. My mom-in-law was checking on me to make sure we're okay because our electricity's been going off and on quite a bit the last couple of days. So it's cold and it's not. Okay. So right now we have electricity on, so that's why I'm doing this. Okay. All right. So does that make a little bit of sense for you? I know it's a lot of information, but we'll review this again. Okay. All right. So that was on page 634. Okay, 635. Okay, and then remember this was Dalton. Okay, he's a scientist that came up with the atomic theory that different types of atoms combine to form chemical compounds. Okay, all right. Oh, so this is fun. Now you guys have all shot off fireworks or been with someone who does. Okay, so compounds are made of atoms of at least two different elements. Okay, so firework colors. Look at this, guys. You have orange, yellow, and red. Pretty common colors of fireworks. Okay, some of the colors in fireworks come from compounds. For example, calcium chloride, which contains 1 calcium atom for every 2 chlorine atoms, results in an orange color. Okay, so here is orange calcium chloride. Okay, so you have 1 calcium, 2 chlorines. Oh, look at that. So it tells you how many atoms you have, doesn't it? So here's my understood 1. I don't have to put the little 1. That's understood. Calcium, and then how many chlorines? I have 2. Okay, so calcium chloride. Okay, and here's my 2 chlorine. Here's my 1 calcium. Okay, for yellow, I have sodium. Oh, here's sodium again, guys. Okay, so that's my Na. And no, you don't have to know how to write these chemically. I just wrote those here for you so you know kind of what we're doing. Okay. So you have sodium nitrate. Okay. Nitrate is another little compound that goes together. So I have 1 sodium, 1 nitrogen, and 3 oxygen. Okay. I still have 1 sodium, 1 nitrogen, and 3 oxygen. Okay. Okay. Lithium carbonate. Carbonate is another little compound. Lithium, I have 2 lithium. Right there it is. Li with a 2. 1 carbon, and I have 3 oxygens. CO3. Okay. All right. So they gave you kind of some difficult compounds, but that's actually where you come up, and that's also why they smell. Because remember, when we light fireworks, that's a chemical reaction, so it's breaking these chemicals apart into something new, and that's why you have the smell, the odor that's produced, and then the pretty colors. Okay, all right. Fructose is often called fruit sugar. Fructose. Okay. So guess what? If it's called fruit sugar, guess where we find fructose? In our fruit, like our apples, our oranges, bananas, okay? All the different fruits, grapes that we like, plums, oranges, okay? So fructose, that's how you say it. So guess what? For every 6 atoms of carbon in the compound, there are 12 hydrogen atoms and 6 oxygen atoms. Ooh, okay, guys, C6H12O6. Okay, so let's write that bigger so you can see it. C6H12O6. And this is fruit sugar. Okay, guys, do you remember when we talked about photosynthesis before Christmas? Okay, this is the fruit sugar. This is the food that fruit or plants make from the sun. Remember that? When we talked about photosynthesis, that's how plants have to have sun. They're the producers. They've got to make their own food too, just like we put it in our mouths. They don't have a mouth, so they have to get their energy from the sun to make their own food. So that's their fruit sugars. Okay? C6H12O6. Fructose. Okay. So here, do the math. Yay! Do the math, do the math, do the math. Okay. So you have says add the total number of atoms in fructose. In lowest terms, what fraction of fructose consists of carbon atoms? Okay, so let's add that together. What's 6 plus 12 plus 6? Add them together. 6 plus 2 is 8. 8 plus 6 is 14. Carry my 1. So I have 24 total atoms. Okay, 24 total atoms. Right? 6 plus 12 plus 6. 24 total atoms. Now, it says of carbon atoms. Okay? Well, carbon atoms, how many carbon atoms do I have? 6, right? Okay? Have you guys done fractions? I think you may be working on that, if that's correct. I think. So I have 6, this is carbon. 6 carbon atoms over a total of 24. If I reduce that to its lowest, do you guys remember how to do that? Okay, to the lowest, if I can reduce my fractions. Okay, I think you guys have learned that. I need to ask Mrs. Spradlin. But 6 will go into 6 how many times? 1. 6 will go into 24 how many times? 4. 4 times 6 is 24. Okay? All right. Then of hydrogen atoms. How many hydrogen atoms do I have? I have what? 12. Okay, and if I reduce that to simplest terms, 12 will go into 12 one time. 12 will go into 24 two times, so 1/2. And then I have oxygen atoms again, which is 6 over 24, and that would be the same, which is 1/4. 6 will go into 6 one time, 6 will go into 24 4 times. Okay? So, like they said, what's the total, what fraction of fructose consists of? Oxygen, 1/4 of it, hydrogen, 1/2 of it, and then the carbon, 1/4. Well, doesn't 1/4 plus 1/2 plus 1/4 add up to 1 whole? Okay? So that's just a little bit of an introduction. We're going to be talking more about this, okay? And hopefully, I will see you tomorrow on Thursday. So hopefully we'll get to school, back to school, because I miss you guys. Okay, please stay safe, and hopefully Miss Goshen will see you on Thursday. You guys have a wonderful, safe day.